Hello, geometry class. This is Miss Myers here, ready to take you through your second set of notes for geometry for the year. You need to make sure that you have with you your note packet, something to write with, and maybe a calculator. Now you may not Now before we begin, if at any time things go a little too fast or you just miss something, feel free to pause the video, rewind, and re-watch anything you may have missed. If that doesn't work and you're still uncertain about something that we've gone over in this video, jot down a question to yourself so that you remember to ask it next time we are in class, and I will be happy to answer any questions that you may have that were not answered in this video. Okay guys, without further ado, let's go ahead and get into our Section 2 notes. Section 2 of Geometry for the year is a section called Segments and Congruence. Our essential question is, what is the difference between congruence and equality? Now hopefully equality is a familiar term, but congruence is going to be something new and different that we're going to be using throughout the year this year. We're going to introduce this topic of congruence today so that we can use it throughout the year. So definitely let's make sure we understand what this new word means. We've got some key vocabulary at the bottom of the page here. Our first two terms go together. There's something in geometry called a postulate, and it is sometimes called an axiom. Both of these words simply mean that they are rules in geometry. They are going to be things that we see throughout the year that tell us how to work with the numbers and the shapes and the segments and different objects we're working with. It tells us how things fit together. Now these particular rules are rules that are accepted without proof, meaning they are the basic building block rules for geometry. They are the things that we do not need to justify. They are understood as basic understanding rules. Now we have another type of rule in geometry called a theorem. A theorem is also a type of rule in geometry, but this one is a little bit bigger. The ideas are slightly more complex, so we have to prove that they are true. We have to justify that we believe these rules work. Our justifications come from things like postulates and axioms and other definitions within geometry. Later in the year, we'll get to how to prove these theorems. For now, just know that there's a slight distinction between these types of rules, the postulate versus the theorem. The next word, between. This is definitely a word you've seen before, but it takes on a special meaning in geometry. When we say one point is between two others, we are implying that that point is actually collinear with the others. So between means it's on the same line. Here's our big term for the unit, congruence. Specifically in this section, we're going to be talking about congruent segments. Now, congruence is an idea that is very similar to equality. In fact, we define congruence using the idea of equality. We say that two line segments are congruent when they have the same length. So if we measure these two segments and we find out that they're both, say, 2 centimeters long, since their lengths are equal, we can say that the segments are congruent. In addition to this word congruent, we have some slightly different notations. Remember, we translate things and we have shorthand in mathematics, and we need to make sure we understand and know what that shorthand looks like. Equality we should be familiar with. Congruence actually looks very similar since it is a similar idea. A congruent symbol is an equal sign, but it has a little bit of a squiggly on top. Let me draw it a little bit larger for you so you can see. Equal, congruence. Now, since these ideas are so similar, it is a little tricky and confusing as to how are they different. On the segment level, they don't have a lot of difference. It's when we get into larger figures that their distinctions become more obvious. For now, know that equality deals with numbers, measurements. We would say that they have equal measurements because they both are, we said, maybe 2 centimeters or however long they are if we were to measure them. So the numbers themselves are equal. The segments, the actual figures, we don't say the segments are equal. The figures are congruent. Think of this another way. Imagine 2 people in your class. You guys are probably the same age. You say that your ages are equal. You do not say that you as people are equal simply because you share a number in common. There are many, many things that make you unique. In order for 2 people to be congruent, they would have to have all of their numbers the same. Are they the same height? Are they the same weight? Are they the same age? All of those numbers associated them would have to be the same to make them congruent. Probably the closest thing we could get to congruent people would be a pair of twins. Even though, yes, twins do have some minute differences, it's the closest analogy we could get to having congruent people. Let's move on. On the next page, we get our first rules. We have a pair of postulates. The first one, the ruler postulate, I'll tell you, is not the most important. We won't see it a lot this year. It simply allows us to set up a measuring system. You know that you can measure in centimeters versus inches. We can change our unit because of the ruler postulate. It simply says if we keep our measurements consistent, we can measure in any unit we want. The most important postulate for this section is this segment addition postulate. This one is going to get used throughout the year. So of these 2, this is the one to study and to know. The segment addition postulate says, simply, the sum of the parts equals the whole. It's a simple idea, one that I'm sure you already know. If we were to look at this segment, and we look at the pieces that the segment is broken into, we have a piece AB, and we have a piece BC. If we were to take these 2 pieces, let's say AB has a length of 5, and BC has a length of 2. We know that we can combine these 2 lengths to get the total length of the full segment AC has to be 7. If we add up the parts, it has to equal the whole. That is the essence of the segment addition postulate. Alright guys, let's get into the examples. There's just a few for this section. Example 1 gives us an application problem for the segment addition postulate. We have a map, we're given a couple distances, and we want to find the remaining distance. Segment addition postulate says the sum of the parts equals the whole. If the whole length between Dickinson and Fargo is 289 miles, and we know this partial length between Dickinson and Bismarck is 99 miles, the remaining length between Bismarck and Fargo is unknown, but can be found simply by subtracting the 99 from the 289. This tells us that there must be 190 miles between Bismarck and Fargo. Example 2 is a very similar problem, only we've removed the map and gone straight to just a geometric figure. We're just looking at segments here. Now there is something to note on the question. It says find CD. Notice that there is no bar on top of the CD. So this is not saying find the segment. Oh look, here's segment CD, I'm done. No. When there is no bar on top of the segment, this translates to saying find the length of segment CD. So this is asking for a numerical answer, and our answer should be written using equality, not congruence. Take a minute, pause the video, find the length of CD before you move on to example 3. Alright guys, example 3. We are almost done with this section. Example 3 says that point S is between R and T on segment RT. Again, notice there's a bar on top telling us that this is a segment, not the length of the segment. The problem goes on to say use the given information to write an equation in terms of x. We want to solve the equation and then find RS and RT. Again, there's no bars here, meaning we want to find the lengths of those two segments. We are then given the lengths of the segments. Some of them are in terms of variables. The ones we need to find, well, we've got to figure out what the variable equals before we can find their lengths. I would highly recommend sketching out a diagram before you begin. Sketching accurate diagrams in geometry can be an extremely helpful tool for you throughout the year. So I'm going to draw segment RT, and I'm going to put S between R and T. Remember, between means collinear. So somewhere on that line segment, it doesn't have to be dead center. These two sides are not necessarily congruent. They could be, but we don't know. So S can float anywhere in between the two. From there, I'm going to fill in the lengths that I know. RS says that it has a length of 3x minus 16. ST says that it has a length of 4x minus 8. And RT has a length of 60. Again, this becomes another segment addition postulate. Recall that segment addition postulate says that the sum of the parts equals the whole. So the lengths of my two smaller segments have to equal the length of the full segment. So all I need to do is set up the equation and solve. Now that it's set up, guys, we've taken care of the geometry portion of this question. So I'm going to let it up to you to finish the algebra. Make sure you do answer the question completely. We are not simply interested in finding x. It's important, but it is not the main goal. Remember to find RS and ST. You need to find their lengths. So think about, what do I need to do with that x in order to find the lengths of these two segments? After you finish that, take a minute and see if you can answer the closure question. Do you remember the difference between congruence and equality? If you finished all of that, folks, you are done with your homework for tonight. You may check your answers to all of these problems on the website. There is an answer key located on the Chapter 1 page. Look for the link that says Chapter 1's Notes Key. Scroll down to section 1.2 and you'll be able to see how you've done. Remember, if you have any questions on this unit, if anything was unclear, definitely make sure to ask me in class tomorrow. Have a great evening, and we'll see you next time.